So today we're going to continue talking about the substitution method with part 3. And in part 3 we'll see that both equations are written in standard form. And to use the substitution method we need to have either x or y solved for. We need x equals or y equals. So one of the variables, could be either one, we need to solve for. The easiest one to solve for is the variable that's by itself. So in this case that y has just a coefficient of 1. Could be the x that's by itself. In this case we're going to solve for the y. So we're going to take that second equation, we're going to get y by itself. To do that, we're going to subtract 3x on both sides of the equation. Cancels out on the left, we just bring down the y equals. We can't combine these, they're not like terms, so we're just going to write 16 minus 3x. And that is going to be the quantity that we substitute. So if y equals 16 minus 3x, then it's going to equal 16 minus 3x everywhere. Specifically, we can take that quantity and substitute it in for y in the top equation. So now I'm going to rewrite that top equation. So we have 2x minus 4, but instead of y, I'm going to write what y equals. I'm going to substitute it out and write 16 minus 3x in its place. Equals 6. It's the same as the top equation, just y is swapped out, and what y equals, 16 minus 3x, is in its place. Now we're going to solve. To do that, we are needing to distribute the negative 4. So we have 2x. If we take negative 4 times 16, we get a negative 64. If we take negative 4 times negative 3x, we get a plus 12x equals 6. We're now going to combine our like terms, specifically the 2x and the plus 12x can be combined. 2 plus 12 is 14x. Bring down the minus 64 equals 6. We're then going to add 64 on both sides of the equation. So that brings us to 14x. The 64's cancel out. Equals 6 plus 64 is 70. We're then going to divide by 14 on both sides of the equation. And we get x equals 70 divided by 14 is 5. And so that is our x value. Now to solve for y, we can take that x value and we can plug it in any equation. I think it's going to be easiest to plug it in right here in this equation that we solve for y. So we have y equals 16 minus 3 times x, but instead of x, I'm going to put 5 in because x was 5 right here. So this becomes y equals 16 minus 3 times 5 is 15, and then y equals 1. So of course we always write our solution as an ordered pair, x comma y. So in this case, that would be the point 5, 1. That's our final answer. So if we were to graph both of these lines, we should see that they intersect at the point 5,